over here, I've got perpendicular line, okay, because the gradient is 2 and that's equal to half. And this has to go through the center, so some center O or some center C like that, okay? And from here, if I have to basically extend each of these to, let's say, a corner over here, there, and this one over here, there, then that's a diameter, and it will be angles in the semicircle, because that's a semicircle, and there's the angle. And this angle is also going to be 90 degrees. And that's going to be 90 degrees angle in the semicircle. And let's try and plot as many different theorems as we can from this. So the block here means 90 degrees. We also know the gradient of these two lines equals 2 and negative a half. I could then provide another line in there. Let's say I provide another line which is going across over here. If I provide another line like that, I know that those two lines coming from the center mean that they're equal because they both are equal to this line as well, because they're all radii. They're all the radius. They all form the exact same length from the center of the circle to the circumference. It's called the radius. So these are all radii. One radius many radii. We've got radius, and then we've got this angle over here, which is 2x, let's call it, which means this angle is going to be x, so the angle at the center is equal to 2 times the angle at the circumference. Now using tan chord theorem, if this angle is y, this angle will be y, and that's because of tan chord theorem. And if I continue, and let's say I try and extend that question into a cyclic chord, so let's say I extend it into some kind of cyclic chord, like that, then we can continue trying to find all the different angles giving all the different reasons. By the way, this angle will be 90 degrees, and the reason is because of opposite angles of a cyclic chord add up to 180 degrees, which means that this angle will also be 90 because angles on a straight line add up to 180 degrees, and that's the exterior angle of a cyclic chord. So now you got the cyclic chord, you got the opposite angles, which is going to be this is 190 degrees, the block there. I could then extend it further and say, okay, well, that's 90 and that's 90, and that is my diameter. Then maybe I can provide another angle, let's say. If I provided another angle, hypothetically speaking, let's say it went all the way this way, over top, and down this way. And let's call this angle y. No, let's call it z. So those two angles will be equal as well, because of angles in the same segment. Which means that this angle is going to be 90 minus z, because angles in a triangle add up to 180 degrees. We could develop all kinds of different angles like this. If I call this angle t, for example, then I know that this angle will also be equal to t. Right, because this is 90, and therefore this is 90 minus z, complementary angles. And so this is equal to t. Alright, so just a quick discovery of if I had to, this is not in particular perpendicular line, but it includes it in there as well. So just a general overview of this.